Okay, so the linear search is really simple, and for small data sets it works just fine. But if you have a lot of data, it can become really slow, and we need to look for another way of searching, and that is the binary search. Now, the limitation is you can only do that on a sorted set of data. And that's because of the way it works. It starts in the middle of the array and then compares the value to that you look for to the middle value. And if the value is smaller, then you know that you have to be in the lower half of the array. If the value that you look for is larger than the middle, then you continue to search in the upper half of the array. And then in those halves it uses the middle of the half, and then so on. So you go in the lower quart or the upper quart, in the lower 1/8 or the upper 1/8. And the search continues until either the value is found or until the lower and the upper bounds meet, because then there's nothing in between, and it's no use continuing to search. If the value is found, the function returns the index of the value, and if it's not found, then it returns the default -1. So over here we have an array of ID numbers, and you see that these are in sorted order. And we have over here 20 of them. So if we look for instance, well, let's say 200, then we pick the middle over here, which would be probably around here, and then we say, okay, it has to be in the lower half because 200 is less than 296. So over here now, this is the area where we look. We pick the middle value, which is, let's say, 199. And you say, well, the 200 is larger than 199, so we need to look in this area over here. And then you go to the middle again and you say, well, 200 is less than 222, so we need to be on the left side. And then you say, not the same, so we haven't found it. So that's how you cut down the search space by half each time. And that's what makes it so fast. So what we need to send it to the binary search function is again the array with ID numbers, over here the size of the array and the value that we look for, in this case the employee ID. And we declare a couple of positions over here, the first, the last, the middle, and the position. Now the last we set to size -1, because the array has a certain size, and you know that we start counting at 0. So let's say that you have 20 elements in the array. They'll have an index going from 0 to 19. We also have a Boolean value that it has not been found yet. So again, we go through a loop over here while it has not been found, and the first and the last do not come together yet. Then we set as the middle the sum of the first and the last divided by 2. Now this is an integer calculation, so if you end up with, let's say, 11.5, then the middle value would be 11 and not 12. And then you look at that particular element in the array, you compare it with the value. If they are the same, you say, okay, I found it, and I found it at this position over here. And when I go back over here to the while, it's now found. This not found becomes false, so we stop immediately. If it's greater than, over here we go to the left half. Oops, didn't need to do that. Then the value is in the lower half over here, and otherwise it's going to be in the upper half. And we do that by setting the first of the partial array that we're looking at the middle +1. So this is the binary search, which cuts the search space into half all the time.